Hello and welcome in video lecture series Demystifying Blockchain. The aim of this video lecture series is to demystify the complex concepts pertaining to blockchain into simplified way so that they are easy to digest. This is the first video of the video lecture series. This video focuses on what blockchain is, why we require blockchain, and a brief overview on the history of blockchain. So we'll start with looking at the definition of blockchain. If we just search internet, you could find multiple definitions of blockchain, right? So here we will see some definitions of blockchain. So looking at the first definition, blockchain is basically a technological mix of different technologies. It involves cryptography, it involves consensus mechanism, it involves peer-to-peer network and game theory. So this video is basically we are trying to build a template, and in coming videos we will try to fill that template so that we have a complete picture of what blockchain is actually. Okay, now let us look at second definition for the blockchain. So for second definition, we will take a simple analogy to understand it clearly, right? So second definition is blockchain is like a linked list, right? But this is built with the help of special links called as hash pointers. So if we look at what linked list is simply a list of nodes connected with a link called as memory pointer, right? So if this is a node and it has a data value as well as a pointer, right, pointing to next node. So another node here, the data, and the pointer to another node, right? So this is about linked list. Well, the same way goes for blockchain. Blockchain is basically a list of blocks connected through a special pointer called as hash pointer, where each block is connected to its previous block, right? To its previous block. If we take this block number 2, if we take this is block number 2, this will be connected to the previous block through a special link called as hash pointer, right? So here in case of linked list we were having data and pointer. Here we will have block header and block body. Inside header there will be a link that is pointing to previous block, right? So here we will be having a link that is pointing to previous block. So this link is basically this, right? This will have a previous hash here, same goes to here, this will have a previous hash, right? So there is a connection between those blocks, and this connection is called as a hash pointer. So this is very interesting because this makes this whole blockchain immutable, because if we try to change even a small information in any block, this will make whole of the blockchain invalid, just because if suppose this has a hash value 1 and this was located here, right? If we try to change some information here, this will not be h1 now, and this will become invalid. And so same goes with every other block, like that is followed by, right, that is following this second block, like third, fourth, fifth, and the list goes on. So that's why this is very special compared to the linked list, right? So this is about the second definition for the blockchain. Now look at the third definition. So blockchain is distributed, decentralized, right, replicated, immutable, all sort of words, right? Let us see how blockchain looks like. If we look at traditional model of networking, right, if we have this node, if this is a single node and we consider it as server, if we look at client server model, then there are multiple clients that are connected to this server, and this server serves those clients, right? So this is like centralized model, right? And there is another model, like we have a node, or you can say a system or whatever. There is a proper term called as node, so we will go with this node. And the control was in case of client and server and client based model. Control was fixed to the single point, right? this was in in the hands of this server, right? So server was in charge. Every decision is taken by the server itself. So the problem with this, with such model, is that there is a single point of failure. If server goes down, everything goes down. But unfortunately, our traditional based application, most of the application are based upon this. Like we have web based model where we have a server like a website that serves us when client try to access those specific pages of any particular website. When server goes down, so we are not able to access. So that's like the problem. We have centralized trust, and there is a single point of failure that we have that problem. If central point goes down, everything inside the system goes down. Now another model is like a decentralized model where this control is distributed, right? Control is not in the single authority. Control is with different. Let's suppose these nodes 1 2 3 are, these nodes have the control, right? So the problem in such such scenarios is that they need to have a consensus with each other so that they have a consistent state of the network, right? So that's why it brings another problem if we try to decentralize the control. So that's why consensus mechanism is there in blockchain that helps us to achieve this distributed trust, right? So there is this decentralized way. Now what about distributed, right? Distribution is also there. If you look at the server based model, there is like a single storage that is located at single place, maybe at the premises of server. So we have a single single place where we have whole of the storage or the data, right? So other problem is that if there is a denial of service, that this server goes down, then a service will not be available for the clients. Now another concept is like, let's try to, I just erase this. We'll see about distributed nature, right? Now how distributed works. So we have the nodes here, and the data is distributed, right? If this is a node 1, node 2, node 3, so the data is distributed. Okay, so every node has its copy. So we say this is distribution. Now the case could be like there is a distribution, but still control lies at the single point, right? That is the case. If we take a simple example, if Google has Google has servers located all over the globe, but the single point is, if we take a simple, just an analogy, the Google is responsible to take decision, though it is distributed, but still it is centralized, right? But in case, if we look, there is distribution as well as decentralization, then these nodes are equal, they have equal power in decision making. So that's what blockchain is. That is, it is distributed as well as it is decentralized, right? So that is about like the first definition or third definition that we have seen. It is distributed, decentralized, immutable, in a sense that you cannot modify the state, just because we have cryptography and all sort of concepts inside the protocol itself that restricts anyone to just modify, right? Then other part is like replicated, that we have a consistent state of the data, right? Whatever is here, but that is also there. So we have multiple copies available of single ledger at different nodes, right? So if see the advantage, if this first goes down, still second can serve. If second goes down, this third can serve. So with this we have like thousands of nodes connected to, just like in networks like Bitcoin, Ethereum, we have lot of like, we have thousands of nodes connected. So it eliminates the problem of a single point of failure. That is like, we have availability here now, right? So this is about another definition. What often I say about blockchain is like, I often heard this is like a trustless technology, but I often better to use like it's based upon a distributed trust, where we trust everyone, right, in aggregate. So now coming back to the presentation, we'll see why we need blockchain. So first we have enhanced security. There is no central point of trust that we have seen. It's open and transparent, that everything is open there, right? So if we go back again, it also provides powerful audit trails, so that whatever we do on the blockchain, that is being like recorded, every action is being recorded, so we could build a strong audit trail mechanism. And we could like store anything any value anything of value that can be digitized. So we often have seen the use cases like we have digitization of assets of various kinds, right? Another reason why we use blockchain has a power to provide proof of stake. What do you mean by proof of stake? That is proof of existence, that something something has happened at particular instance of time. Proof of ownership, who owns what, like under what circumstances that ownership has been transferred. That is also the power of blockchain. We have proof of integrity, that something is correct in its state, right? If something is like, if blockchain shows that this has the state of this nature, and after like few months this has changed to this. So blockchain is built with very strong cryptographic techniques, so that it gives us a sense of that there is a proof that nothing has been modified. Proof of provenance, again, because of its transparent nature, because of it is design, by design it provides proof of provenance, because you can prove history of owners. If we look at a simple example and a use case of land records, we could build on top of blockchain. It can show who has owned what, and when he has transferred it to someone else. So everything can be tracked, and everything can be recorded, everything can be tracked, and everything can be like proved with 100% certainty on top of blockchain. So another is traceability, is very related to provenance. It allows you to have a very strong audit trail and trail of movement, right? Now we will look at the brief history of blockchain. So in 1991, two scientists, Stuart Haber and W. Scott Stornetta, they try to use the concept of chaining blocks in order to prevent documents from being backdated and from being modified. So they basically try to use a concept of hash in order to prevent backdating and the forging of documents by time stamping them, right? Then in 1998, Nick Szabo proposed decentralized digital currency called as BitGold, but this attempt failed just because it was not able to produce a very solid mechanism for bringing distributed trust in trustless environment, right? So in 2000 there has been other attempt using those secured chains, cryptography based secured chains. Nick Szabo's attempt was just a proposal. This was not an implementation, so it was lacking the implementation itself also. In 2008, this has bring the revolution. Satoshi Nakamoto, whose identity is not known, it could be a single person or a group of persons, right, has released a white paper, and that describes every sort of like components of a working model for a blockchain. So that's considered to be like a single document with every sort of detailed information to implement that. So Satoshi Nakamoto released this white paper. The name of the white paper was a peer-to-peer electronic cash system. So in early 2009, Satoshi Nakamoto implements the first blockchain as the public ledger for transactions, and that is called as a Bitcoin. So Bitcoin is the first successful application of blockchain. So even though we come to know about blockchain based upon Bitcoin, but actually the technology behind the Bitcoin is blockchain itself, right? So in 2014, blockchain technology was earlier restricted with very like, it was not that powerful, like, because Bitcoin was based upon a scripting language based stack based scripting language with very limited potential. in a sense that that was Turing incomplete, because we cannot realize all the logic that we have in the mind, because it doesn't support that programming language where we could write every sort of logic, right? But in 2014, or you can say late 2013, Vitalik Buterin proposed this beautiful model, like we could write programs on top of blockchain, right? It proposes like, you know, it just paves way for writing and building applications that are beyond cryptocurrencies, right? So we say that in from 2014 blockchain 2.0 is born, like it allows us to have applications beyond cryptocurrencies, just because we are able to run, you know, run programs on top of blockchain now. So he proposed this technology called as Ethereum. So this is brief about the history. There has been several other attempts, but these are notable events that we have described here. So this is it about, you know, today's video. In next video we will try to go deeper into the concepts and try to, you know, fill our template so that we have complete understanding of how blockchain works. And then we will follow about, we will try to learn about Bitcoin, what Bitcoin is actually. We will try to publish multiple videos on that so that we have conceptual understanding about that. Then finally we will go to the Ethereum and we will see all the aspects of Ethereum, and in final videos we will try to use smart contract language, try to build applications. So this is like a path we'll see. So if you like the content, please hit the like button of the video, try to subscribe to the channel, and that's it. Thank you.